Hello everyone, welcome back to my YouTube channel. My name is Srishti. I'm in my second semester studying in Sri Venkateswara College of Engineering in the Department of Computer Science. Today I'm going to talk a few points on the topic e-waste and management and how it is important to recycle. Moving on to the contents of this video, there is the definition of e-waste, the composition of e-waste, sources, environmental impact, health concerns, e-waste management practices, regulations and recycling and the types of recycling. Let's learn about the definition of e-waste. E-waste is an abbreviation which is used for electronic waste or electrical waste. Electronic waste, commonly referred to as e-waste, is a term used to describe discarded electrical or electronic devices. These are basically out-of-date products which cannot be further used. These devices can range from everyday household items like smartphones, laptops, and televisions to a larger appliances and industrial equipment. E-waste can be significant environmental and health concern due to the hazardous material it often contains and the improper disposal method commonly used. Let's move on to the composition of e-waste. E-waste consists of a wide variety of materials including plastics, metals such as gold, silver, copper, and rare earth metals, glass, hazardous substances like lead, mercury, cadmium, and flame retardants. The mixture of valuable and hazardous materials make e-waste complex to manage. The components of e-waste are given in this graph. The rubber is of only 1%, printed circuit boards are of 2 to 3%, plastics, flames, etc. are of 3 to 8%, metals non-ferrous are from 13 to 15%, and metal ferrous are 48%. Moving on, we have sources. The sources of e-waste are wide. It can range from household products to medical equipments too. It can range from even small retail shop to huge commercial or MNC companies. E-waste can come from various sources including consumer electronics, information technology, equipment, communication devices, and household appliances. As technology advances and product life cycle shortens, the volume of e-waste generated globally continues to increase. In this image, you can see the sources of e-waste: commercial sector, institutional sector, R&D organization, manufacturing, industrial sectors, household sectors, local collectors, stockists, etc. Here Here it shows the sources or the percentage amount of retail and household e-waste. Refrigerators are about 20%, electronics are about 15%, television are about 10%, monitors are about 10%, IT/AC equipment are 15%, and other household appliances are 30%. Let's move on to the environmental impact. Any kind of waste, let it be e-waste, solid waste, chemical waste, industrial waste, causes environmental impact and health impacts on organisms present on Earth. So let us learn about the environmental impacts of e-waste in this slide. When e-waste is improperly managed, it can have severe environmental consequences. Toxic substances present in e-waste can leach into soil and water, contaminating ecosystem and posing risks to human health and wildlife. Improper chemical methods such as open burning and dumping release harmful chemicals. You can see this graph which shows us the percentages of e-waste and on different kinds of pollution, such as air pollution is of 30%, soil contamination is as high as 38%, health problems caused by e-waste is 24%, and there are physical injuries also present in e-waste, which is of up to 8%. Let's move on to the health concerns. E-waste workers, especially in developing countries, are often exposed to hazardous materials while dismantling or processing e-waste. Prolonged exposure to these substances can lead to various health issues, including respiratory problems, neurological disorder, and certain types of cancer. This image right here shows the harmful health effects of e-waste. The e-waste or the effects of e-waste are mostly to the people who work in e-waste management and the people who live nearby the contaminated area of e-waste. The harmful health effects of e-waste here given are vomiting, muscular pain, fatigue, headache, sleeplessness, lung cancer, abdominal pain, appetite loss, and diarrhea. Let us learn about how different types of materials or different types of metals or substances present in e-waste can harm a human body. This image right here shows us the different types of e-waste or the materials present in e-waste which causes different types of harmful effects on our body. Dioxins damage the immune, nervous, endocrine, and reproductive systems. Lead causes cognitive and verbal impairment, especially in children. Arsenic contributes to cancer, diabetes, and cardiovascular diseases. Copper negatively affects the lungs and kidneys. Cadmium weakens the bones by interfering with the body's ability to metabolize calcium, and mercury poisons the eyes, skin, lungs, kidneys, and nervous, digestive, and immune system. E-waste management practices. E-waste management practices include refurbishing and repairing devices for reuse, recycling to recover valuable materials, and proper disposal of hazardous components. These practices can help minimize the environment and health risk associated with e-waste. These are the few reasons why e-waste management should be there. First one is pollution of groundwater, acidification of soil, emission of toxic fumes and gases, the fastest growing portion of municipal waste, and releases carcinogen substances into the air. The few regulations which has to be followed while recycling e-waste. So now let's learn about the regulations and recycling and the types of recycling of e-waste. Many countries have implemented regulations and guidelines for the proper disposal and recycling of e-waste. These regulations aim to reduce the negative impact of e-waste on the environment and human health. Proper recycling involves the recovery of valuable metals and the safe disposal of hazardous components. This image shows us how the regulations for the disposal of e-waste was made possible. The first one is a brief overview of global e-waste scenario. Next, the e-waste legislation worldwide, e-waste management issues in countries implementing legislation, generic e-waste management models, which brought us towards formulating an effective e-waste legislation. Now let's learn about recycling of e-waste and types of recycling. Recycling e-waste is essential for reducing its environmental impact and promoting the responsible management of electronic devices. Various recycling methods are used to recover valuable materials and minimize the negative effects of e-waste. Here are some common e-waste recycling methods. The first one is pyrometallurgy, which uses energy-intensive smelting. The second one is hydrometallurgy, which involves treatment with strong acid. The third one is biohydrometallurgy, which harnesses natural biogeochemical cycling. In this video, we're going to learn about pyrometallurgy and hydrometallurgy. Let's move on to hydrometallurgy processes. This process involves the extraction of valuable metals such as gold, silver, and copper. This process has three stages. That is, first one being pre-treatment stage, second one being chemical treatment stage, and third one being metal recovery stage. Let's learn about hydrometallurgy. These processes involve the use of chemical solutions to dissolve and recover metals from e-waste. Leaching is a common hydrometallurgy technique where valuable metals are dissolved into a solution and then the metals are recovered through precipitation or other methods. Image shows us the hydrometallurgy process. As I've told, there are three major steps in hydrometallurgy process. The first one being the pre-treatment stage. In this stage, there is physical separation of e-waste and the physical dismantling of e-waste into its different compartment parts, such as circuit boards, metals, and plastics. The second stage in hydrometallurgy process is chemical treatment. In this chemical treatment, there is leaching of the metal or the metals found. There are different types of leaching. The different types of leaching are present in this image. Acid leaching using HCl, H2SO4, and H2O2, and H3PO4, alkaline leaching, and organic leaching, and bioleaching. These leaching processes form a metal slurry, which makes it easier for them to differentiate between the metals and the solid waste. The third step is metal recovery. In metal recovery, there are stages such as cathode recycling, present in the image, and precipitation and ion-ion exchange, through which the valuable metal is extracted. Pyrometallurgy process. Pyrometallurgy process is usually used for the extraction of metals which are non-ferrous, like aluminium, copper, lead, etc. Pyrometallurgy process involves two steps followed by hydrometallurgy process. These two main steps in pyrometallurgy process are pre-treatment stage and metal recovery stage. Pyro means fire or high temperature. You can guess from the word pyro that in this process, high temperature of fire is being used for the extraction of e-waste. Pyrometallurgy involves using high temperature to separate and recover metals from e-waste. It often involves processes like smelting and refining. While effective for some materials, pyrometallurgy can release pollutants and require careful management to minimize environmental impact. This image above shows us the uh, steps which are required for pyrometallurgy. Here, the e-waste is collected and smelting or blast furnace is used. The dust is moved to exhaust cleaning. Then this product obtained in smelting or blast furnace is gone to the converter, which is then gone to the anode furnace. All the dust collected from these three stages are moved to the exhaust cleaning. The slag, which is used or which can be used again for extracting other materials, is sent back towards the smelting or blast furnace. The other products which are used or which are obtained is gone to electrolysis, where electrolyte to recycling metal deposited cathode and anodic sludge is obtained, and the proper metal or the extracted metal is obtained. Moving on to direct recycling. Direct recycling is another process of recycling which does not use much products like which are used in hydrometallurgy and pyrometallurgy. Let's learn about direct recycling. Direct recycling of e-waste refers to the process of reusing or reclaiming electronic components and materials from discarded electronic devices without going through extensive pre-processing steps. This step include collection and transportation, disassemble, sorting, and then recycling the products or the components which you find. This image right here shows us the different steps which are included in direct recycling. We have now come to the end of our video. I hope you liked this video and I hope I was helpful in understanding the different type of e-waste recycling and how e-waste is harmful for us. Please do like, share and subscribe.